Space is often described as empty, but emptiness is one of the greatest misunderstandings in astronomy. Even the most remote regions of the universe are filled with radiation, particles, and faint light traveling across unimaginable distances. Light is persistent. Once created, it usually continues until something stops it. A star can burn out, a galaxy can collapse, but the light they release continues to move outward, sometimes for billions of years. That is why what astronomers found in a certain region of space was so disturbing. Not because something violent was happening there, but because something subtle was. At first, it appeared insignificant, a patch of sky where stars seemed slightly dimmer than expected. Not missing, just weaker. Astronomers assumed it was dust. Cosmic dust clouds are known to block and scatter light, creating dark patches when viewed from Earth. But when instruments adjusted for dust interference, the darkness remained. And when different wavelengths were used, the results became harder to ignore. Visible light faded, infrared weakened, even background radiation showed signs of disturbance. It was as if something in that region was actively removing light from existence. This was not how black holes behave. Black holes are dramatic. They announce themselves through violent accretion disks, powerful jets, and gravitational lensing that bends light in obvious ways. This region showed none of that. No intense gravity wells, no surrounding chaos, no glowing edges. Just a gradual loss of brightness that increased the closer observations came to its center. Astronomers began mapping the area in detail. The region was vast, spanning distances that dwarfed entire solar systems, and it was not empty. Matter existed there, sparse but present. Gas clouds passed through it, photons entered it, but something changed once they did. Over time, anything that relied on energy began to weaken. Signals passing through lost strength, light lost clarity. Even time measurements showed minor inconsistencies, as if the passage of time itself behaved slightly differently within that space. The most unsettling part was the gradient. The effect was not sudden. It did not destroy instantly. It worked slowly, almost gently. The closer something came to the center, the more it faded, not just visually, but energetically, as if the region was not crushing matter, but draining it. This led to uncomfortable questions. Physics is built on conservation. Energy changes form, but it does not simply vanish. Yet here was a region where energy appeared to be going somewhere unknown, not radiated outward, not transformed into heat or motion, just gone. Some scientists proposed that the region might represent a flaw in our understanding of space-time. Perhaps energy was leaking into extra dimensions predicted by certain theoretical models. Others suggested a form of vacuum decay, where space itself transitions into a lower energy state, pulling everything around it down with it. These ideas were speculative, but they shared one implication. The region was not just strange, it was dangerous. Not in an explosive way, in a quiet one. Imagine drifting into a place where nothing attacks you. Nothing breaks you apart. Nothing announces your end. You simply lose energy, slowly. Your atoms still exist, but their interactions weaken. Light emitted from your body fades before it can escape. Over time, you would become invisible, not because you disappeared, but because the universe no longer registers you. This is what disturbed researchers the most. The region did not look hostile. It looked calm, silent, empty, but it was not neutral. As observations continued, another detail emerged. Objects passing near the region showed subtle trajectory deviations, not enough to suggest massive gravity, but enough to indicate influence. Something was shaping space locally, creating a slope that matter naturally drifted toward, not falling, but sliding, like water toward a drain that does not splash. This raised a terrifying possibility. What if the region was growing? Measurements over time suggested a slow expansion, not rapid, not exponential, just enough to notice when data from different years was compared. If the region continued expanding at the observed rate, it would not threaten Earth for millions of years. But the timescale was not what unsettled scientists. It was the principle. Regions of space are not supposed to behave like this. In normal cosmic voids, matter is simply sparse. Light passes through unimpeded. Here, space itself appeared altered, as if the rules had changed locally. Some researchers began referring to it unofficially as a sink. Not a hole, not a void, but a sink in the fabric of reality where energy slowly drained away. The name never appeared in publications. It was used in private conversations, in notes, in moments when language struggled to keep up with observation. There is a reason this discovery did not become public knowledge immediately, not because of a cover-up, but because it did not fit into any narrative. There was no explosion, no catastrophe, no alien signal, just a quiet implication that parts of the universe might be fundamentally unstable. Human intuition is poorly equipped to fear slow things. We fear impact, collision, collapse. But the most dangerous processes in the universe often operate silently over immense spans of time. Radiation exposure, orbital decay, entropy. This region represented entropy with direction. If such regions exist elsewhere, unnoticed, then the universe may not be a static stage where events unfold. It may be an environment with currents, places that pull reality apart, not through force, but through subtraction. One hypothesis suggested that the region could be a scar, the aftermath of an ancient event that altered space-time permanently. Perhaps a collision between cosmic structures, or the remnants of an early universe process we no longer observe. If so, the region was not active by choice, it was simply damaged. Another hypothesis was far more unsettling, that the region was doing exactly what it was supposed to do. In some models of the universe, stability is not guaranteed. Certain configurations of space-time are metastable, meaning they appear stable until something triggers a transition. When that happens, the new state spreads, slowly, relentlessly, consuming the old configuration as it expands. If this region represented such a transition, then it was not erasing light, it was redefining reality. Nothing dramatic would happen at first. Stars would dim, energy would weaken, chemistry would fail, life, dependent on delicate energy balances, would simply cease, and the region would continue expanding, indifferent to what it consumed. This is not a prediction. It is a possibility, one among many. But it is a possibility grounded in mathematics, not imagination. The universe has no obligation to remain friendly to complexity. Further observations were limited, not because scientists lost interest, but because there was only so much that could be learned remotely. Sending probes was not an option. Even if such technology existed, it would take thousands of years to reach the region, and no instrument could transmit data back if its energy degraded before the signal escaped. So astronomers continue to watch, to measure, to compare faint differences in starlight and background radiation. The region does not respond. It does not change behavior when observed. It does not accelerate. It does not slow down. It simply continues being what it is. A place where light does not escape, not because it is trapped, but because it no longer matters. There is something deeply unsettling about that idea. Not that the universe can destroy us, we have always known that, but that it might do so without violence, without notice, without intention. In such a universe, survival is not about avoiding impact, but about understanding currents we barely perceive. For now, the region remains distant, a quiet anomaly in a sky filled with wonders and dangers alike. But its existence alone changes how we think about space. It suggests that emptiness is not passive, that darkness can have structure, and that the universe may contain places where reality itself slowly unravels, one photon at a time. And if that is true, then silence is not the absence of activity. It is the sound of something being erased.